Welcome, and thanks for joining us. My guests today are Mark Johnson, the Vice President of Federal Technology at IBM, and Leon Platts, the Vice President of Cloud HPC at IBM. Gentlemen, thanks for joining me.
Thank you for having us.
Thank you.
All right, and just to focus the conversation here, it's been an interesting past couple of years in terms of the healthcare space. Mark, let's just start with you here in terms of where the industry is going in terms of the focus of government spending and attention on healthcare. Where do you see things going?
Thanks, Joy. There have been a lot of new initiatives coming out from the administration around healthcare and improving citizen health. Some of the big things are managing those costs. Federal expenditures are expected to climb to $2.2 trillion per year by 2030. And we have to get our arms around managing that information and that cost and spend and what we're getting for outcome. Not just improving the outcomes, but improving the outcomes for everyone, making sure it's an equitable outcome, including underserved communities. We also want not just physical health, but mental health as well. We know that's a crisis right now across a lot of different organizations and groups within the United States, and we're attempting to address those. Climate change is a big effect to our health, and we're seeing that right now with air quality in cities along the Eastern Seaboard. And then ultimately, we have to protect citizen data. These are the biggest initiatives at the high level that federal agencies are attempting to address today.
All right, and we're seeing a lot of emerging technology addressing some of these issues that you just mentioned here, Mark, among them cloud, cyber, artificial intelligence, and a whole other suite of things. How do you see these emerging technologies being part of this solution going forward?
Fantastic question. And it's up to industry really to work with federal government to bring all these disparate technologies that some are just emerging, right? We're talking about AI, which you mentioned, and the generative AI, and people are just starting to envision what can be done with those things. Internet of Things and wearable technologies are a big part of attempting to gather the data on a variety of different groups within our citizens. And collecting that means we have a new problem of too much data, right? How do we get knowledge out of that data? And big data was very popular, 10, 15 years ago. It's still a problem out there, and how do we apply it? Cloud is a way to kind of put our arms around that, manage that data, but to really discover new things and to be able to apply those to health outcomes, it takes machine learning and AI. Only the computers and the capability of really high performance computers are able to go through all that, find what matters, and then result in outcomes that, for instance, the VA is trying to address with our veterans community for addiction and mental health issues. Health and Human Services have big initiatives around equity, as we mentioned, and personalized healthcare, applying the right medicines in the right quantities to each person out there. How do we put that together? Well, it's with high performance computing, artificial intelligence, and then making sure that we wrap all that with the latest and greatest cybersecurity tools so that personal information of our citizens' health is protected. It only belongs to them and their healthcare providers.
Well, Mark, you really highlighted some agencies that have just a ton of data and a ton of information that they have to sort through here. Leon, just for the benefit of our audience here, can you break down how supercomputing differs from high performance computing?
Fantastic. Yes, thank you, Joy. A real pleasure to be speaking with you today. So supercomputing typically refers to the process of complex large calculations used by supercomputers. High performance computing is the use of multiple supercomputers to process complex and large calculations. Both terms are often used interchangeably. The term supercomputer came into the mainstream in the early 1960s when IBM rolled out the IBM 7030 Stretch, and Sperry Roy Rand unveiled the UNIVAC LARP, the first two intentional supercomputers designed to be more powerful than the fastest commercial available machines at the time. High performance computing is the technology that uses clusters of powerful processors working in parallel to process massive multidimensional data sets like we've been talking about, big data, solves really complex problems at extremely high speeds. HPC systems typically perform at speeds more than 1,000,000 times faster than the fastest computer or desktop laptop that you may have in your house or business today.
All right. Well, just to unpack some of the use cases here, what is top of mind for you in terms of this healthcare space? How is HPC really driving things there, Leon?
High-performance computing applications are driving a continuous innovation in healthcare, genomics, and life sciences. For example, the first attempt to sequence the human genome took about 13 years. Today, a high-performance computing system can do that job in less than a day. Other HPC applications in healthcare and life sciences, they include drug discovery and drug design, cancer diagnosis, and molecular modeling. High-performance computing is also prevalent in the government and defense. Two growing HPC use cases in this area is weather forecasting, which is very relevant for today, climate modeling, both of which involve processing vast amounts of historical meteorological data and millions of daily changes in sensors all around the world to predict climate-related data patterns. Other government and defense applications include energy research and intelligence work.
Okay. All right. Well, just to specify things here a little bit, what unique opportunities does IBM HPC bring to solve these problems here? Leon, let's stay with you.
Well, there are three things that differentiate IBM from the competition, I think, in this space. IBM has a really deep knowledge. For 60 years, we've been working in this space. So it's about knowledge. It's about the technology. High-performance computing breaks down really into three segments or three components. One is the application, the problem you're trying to solve for, whether that's the weather, whether that's the cancer treatment, whether that's intelligence. Two, it's the scheduling of all those computers and all those clusters. How do you actually make use of them all at the same time and bring it all together? And then three, it's the actual infrastructure, the computers that sit underneath and actually do all the work. So it's about the technology, but you really, you need that knowledge, you need the technology, but you also need the governance. How do you make sure you don't just build a system for system's sake? You've got to have the governance to make sure you deliver the outcome and the benefits to the businesses or to the government, and ultimately to those who need those benefits and who need those solves.
Yeah, I think that's a great thing. If I could add into that, Jory, is it's really an industry problem, like I talked about before. This is going to take a collaboration of a lot of different organizations that have skills around all the technologies and the problems that Leon mentioned, and bringing those to bear for the federal government. Reaching outside of healthcare into things like energy to supply clean, safe energy for the future that then affects the climate, which then affects healthcare, right? And so you look at longer term solutions there, and being able to apply massive amounts of data and high performance compute with the right application, like Leon was just mentioning. You have to have the people within the government which understand the mission of the government and what they're trying to do to drive those applications for the right outcomes. And despite all this capability we talk about with conventional compute and data management, there are still problems out there that are intractable for these kind of solutions, such as protein folding problems and complex multi-drug interactions that are important for healthcare outcomes. And for that, we do have a new emerging technology, which is really cool, called quantum, which can solve these problems in ways that have never been envisioned by conventional compute. And for that, we have our colleagues, John and Amit, who will talk about some of those capabilities.
All right. Well, just to wrap things up here, we've focused really a lot on healthcare in terms of this conversation, but beyond healthcare, where do you see the government focusing its attention on all these emerging technologies that we've discussed here? Mark, let's go with you.
Hey, thanks. I think it's really important in agencies like Department of Defense, Department of Energy, Department of Interior. They have huge problems, big data sets, and are always looking for better outcomes. High performance computing brings those kind of solutions to AI, being able to train the models, to being able to watch for bias, being able to predict where things are coming from, being able to handle the massive amounts of data that each of these have and apply that to machine learning. So we have great solutions with NASA in collecting data from space and from other planets and being able to apply that to our own planet, right? And how we are able to better manage the environment. The Environmental Protection Agency is helping by measuring massive amounts of data from unfortunate accidents like train derailments that are able to then apply that to ways to clean things up the best and making sure that citizens are kept safe and kept out of the area for as long as possible. Department of Defense always looking for quicker decision making, being able to bring in humans, the data, right data to the human at the right time, because it's not about autonomous weapons and vehicles, which some people are afraid of with AI, justifiably. It's about applying the right information so that a human can make a decision faster and better to make the right outcome. These are the kind of things that other agencies are getting from high performance computing, AI, and the other technologies we've mentioned.
All right. And Leon, to bring things home here, where do you see things moving beyond the healthcare space in terms of this emerging technology in government?
So I think we'll see the likes of HPC really infiltrating all segments of government, because as we get more data, we've got to do more with it. And these kind of technologies really enable us to take that data, find the patterns, and determine, what that data is telling us and make really smart decisions. So, this has been used a lot in the climate change space, trying to predict the weather, trying to understand the impacts of climate change. And I think that same learning will take that kind of use case and will apply the same learnings to other areas of the government to really refine and perfect the outcomes that we can deliver back to all of the different agencies and ultimately the population that benefits from those government agencies.
All right. Well, we've covered a lot of ground here today, but I think we're going to have to leave it there. I'd like to thank today's guests, Mark Johnson, the Vice President of Federal Technology at IBM, and Leon Platts, the Vice President of Cloud HPC at IBM. I'm your moderator, Jory Heckman, and you're watching Federal News Network. Now let me send you back to the studio for more on the Cloud Exchange.